Hi everyone, I am Anton from University of Maryland College Park. Today I will be presenting our work AV-RIR, Audio Visual Room Impulse Response Estimation. Room impulse response is a fundamental concept that characterizes how an acoustic space affects the sound, essentially representing the transfer function between a sound source and a receiver, encapsulating all direct and reflective paths that sound can travel within any indoor or outdoor environment. We can break down the clean speech content and the room impulse response corresponding to the recorded reverberant speech at the receiver end as shown in the below equation. Estimating room impulse response from the reverberant speech is vital for varieties of application, including speech processing application and augmented or virtual reality. Audio-only room impulse response estimation techniques are capable of estimating early components and are not effective in estimating the late components because the early components of the room impulse response have impulsive sparse components, while the late components have a noise-like structure with significantly low magnitude compared to the early components. Visual-only room impulse response estimation demonstrates feasibility in predicting late components from the RGB image of the environment. However, these approaches are not effective in estimating early components as single RGB image does not have enough information like the 3D geometry, information about the material properties of the objects in the environment, speaker position, etc. Considering the limitations of the prior works, we propose AV-RIR, a novel, multi-modal, multitask learning approach for room impulse response estimation. Our AV-RIR employs a neural codec-based multi-modal architecture that inputs audio and visual cues and proposes novel Geo-Mat feature that captures room geometry and material information. We also propose CRIP to improve the late dereverbation of the estimated room impulse response using retrieval and observe that CRIP improves late dereverbation by up to 86%. AV-RIR solves auxiliary speech dereverbation tasks for learning room impulse response estimation. Through this, AV-RIR essentially learns to separate clean speech and the room impulse response. The following figure shows the overview of our AV-RIR learning method. Given the input reverberant speech from any source environment, the primary task of AV-RIR is to estimate the room impulse response by separating it from the clean speech. The input reverberant speech is first encoded using a reverberant speech encoder. The latent output is then passed to two different encoders in two different branches. While one of these branches solves the room impulse response estimation task, the other solves the speech dereverbation task by estimating clean speech. Output from both the speech dereverbation encoder and the room impulse response encoder are fused with ResNet encodings from the panoramic image and the Geo-Mat feature, respectively. The output later multimodal encodings are then passed to a trainable residual vector quantization module, which quantizes to the latent codes. Finally, the hyphen vocoder decodes the enhanced speech, and the room impulse response decoder decodes the estimated early components of the room impulse response, which are used to calculate losses for training. At the inference time, our CRIP retrieves the RIR from a database and is used to improve late dereverbation in the estimated room impulse response. Finally, post-addition, the final estimated room impulse response is convolved with any clean speech to make it sound like it was uttered in the source environment. Now let's look at our proposed Geo-Mat feature in detail. Our Geo-Mat feature represents the geometry and the sound absorption properties of materials in the environment. Physics-based room impulse response simulators takes the 3D geometry of the environment and the material absorption coefficients of each material present in the environment as input to accurately generate room impulse response for that environment. On the other hand, prior work showed that leveraging depth map improves the performance of audio-visual dereverbation. Inspired by these techniques, We propose Geo-Mat features to improve the AV-RIR's understanding of geometry and material information of the environment. Our proposed Geo-Mat feature is a three-channel feature map constructed before training our AV-RIR using the absorption coefficients as the first two channels and the depth map as the last channel. We represent Geo-Mat features with three channels to encode Geo-Mat features using commonly used image encoders like ResNet. We train our neural codec architecture end-to-end to estimate the early components of the room impulse response. We propose CRIP to effectively retrieve the late reverberation effects of the room impulse response. The following figure illustrates our contrastive room impulse response image pre-training network. Like CLIP, we propose two networks, one to encode the panoramic image and the other to encode the room impulse response to learn a joint embedding space between both. We use our CRIP-based image-to-room impulse response retrieval during inference to improve late reverberation in the estimated room impulse response from our AV-RIR. We qualitatively evaluate the benefits of our approach in two different tasks. They are novel view acoustic synthesis and visual acoustic matching. In the novel view acoustic synthesis task, given the audiovisual input from the source and the target viewpoint, we modify the reverberant speech from the source viewpoint to sound as if it is recorded from the target viewpoint. In the visual acoustic matching task, we resynthesize the speech from the source environment to match the target environment. In novel acoustic synthesis task, we first estimate the enhanced speech from the source viewpoint audiovisual input. The room impulse response of the target viewpoint is estimated from the target viewpoint audiovisual input. The target room impulse response is convolved with the source clean speech to synthesize speech for the target viewpoint.
In this connection, it should be mentioned that the Association of Edison Illuminating Companies In this connection, it should be mentioned that the Association of Edison Illuminating Companies In this connection, it should be mentioned that the Association of Edison Illuminating Companies In this connection, it should be mentioned that the Association of Edison Illuminating Companies
In the visual acoustic matching task, the reverberation effects of the input clip from the source environment is matched to the target environment condition. From our AV-RIR, we first estimate the enhanced speech from the source environment. We estimate the room impulse response of the target environment from the audiovisual input. The target environment room impulse response is convolved with the source environment clean speech to synthesize speech for the target environment.
Then they started on again, and 2 hours later came in sight of the house of Dr. Pipt. Then they started on again, and 2 hours later came in sight of the house of Dr. Pipt. Then they started on again, and 2 hours later came in sight of the house of Dr. Pipt. Then they started on again, and 2 hours later came in sight of the house of Dr. Pipt.
Thank you.